We'll start our lesson today on surface areas, lateral surface areas, by talking about the surface area of prisms. So first of all, what is lateral surface area? Well, it's lateral, again, remember, is the side, what goes around, not the bases, but the lateral faces if they're polygons, or the curved sides if they're not polygons. So here you can see it's one lateral face, another lateral face, and another lateral face. So it's what goes around the side of the solid. For prisms, one thing we look at is that the prism parts, there are two base polygons. So you can see that this is a pentagonal prism on top. So there's two polygons. Here's one on top, one underneath that you can't see. Then it tends to have n rectangular lateral faces. Now, if it's a regular polygon, all of these will match. And if it's not regular, that means that all the sides don't match, then the faces might be different size rectangles. So here are the lateral surface of this pentagonal prism. And one of the things we know is that the height of this rectangle is the same as the height of the prism. So this h is the same as the height of the prism. The base of the rectangle right here is the same as the perimeter, the distance around the pentagon in this case. So you can say that the lateral surface area, since that base is the perimeter, and it doesn't matter if it's a regular polygon or not here, it's going to be the perimeter around this base. Then here, and I'm trying to not confuse big B, which is the base, with little b, which is the base of, say, a rectangle or parallelogram. So this distance is a perimeter around that polygon. And so just to get the area, since we know that this is a rectangle, base times height, well, the base we said is the perimeter. That's where this formula comes from. In this example, I do not have a regular polygon as the base. And you can see that this is a prism because the sides are rectangles and the bases are triangles. In fact, they're right triangles. Now, if it's here's the base right here. If it's a right triangle, you can see there's the 13, there's the 12, and there's a right angle, and there's x. Well, I'm going to try to find the lateral surface area, which is this shape right here around the sides, not the triangle part. But this will come into play. So how do I find that again? Our formula is area equals perimeter times height. And the perimeter in this case is going to be this distance around this triangle. Well, that means I need to find x here, this missing side. Well, I can use Pythagorean Theorem because it's a right triangle. 13 squared equals x squared plus 12 squared. Go ahead and square everything. Subtract 144 from both sides. And I get 25 equals x squared, or 5. You may recognize this triangle. This is the 5, 12, 13 triangle. Very handy Pythagorean triple. Okay, so now I know the side here is 5. So I can find the perimeter. It's 5 plus 12 plus 13. When you add those all up, you get 20 millimeters. Finally, we can find the area. So I'm going to put the 20 in for the perimeter, and the height is this distance here, 10. It's the one that's not one of these sides of the base. So substituting in, area equals 20 millimeters times 10 millimeters, or 200 millimeters squared. So for this section of notes, think about what is lateral surface area. Can you answer that question on your own? What shape is the lateral surface for prisms? And where does P come from in the formula for the lateral surface area of a prism?